Hey everyone, welcome back to Flight School. In a previous video, I showed you about a feature in Goose called Headless mode that lets you use Goose without a UI. It's great for servers, CI/CD, cron jobs, and so on. Today, I'm going to take you into more detail on how I'm using Goose in a CI/CD pipeline with GitHub Actions to run Goose in a Docker container. Let's take a look at the project I'm building here. At a high level, I've been using Goose to develop a security scanner for Goose recipes from within a Docker container. Here's the workflow so far. A user submits a Goose recipe through a GitHub issue, then a GitHub action tags it for a security scan and starts building a Docker container. Goose runs within the Docker container so nothing can get out of the sandboxed workspace, and we return a result of how safe the recipe is. Let's take a look at the Docker setup. That Docker container will include a handful of security tools, and then we install the Goose CLI into the container, plus a configuration file for it to use our LLM. The very last line in our Docker container launches our security scanner. This defines a base recipe that we're handing to our Goose CLI setup that will tell it what kinds of things to look for in the recipe submitted by the user. Now, I won't show you the whole script here because it's a couple of hundred lines long. Goose wrote most of this for me, but we can see here that this is the user's input recipe. We have an output folder of where we're going to put our results, and we also tell it where to find Goose, as well as a base recipe that I'll show you next. This is the point in our security scanner script where it's actually running Goose in headless mode. This is the base recipe I'll show you next. This is where we're finding the user's recipe and so on, as well as where we expect to put our output. The rest of the script is interpreting the output from Goose into a scoring mechanism that tells us if the recipe looks safe or not. And finally, we reformat that result back into a GitHub issue as a response so the user can see what Goose found for us. But let's take a closer look at the base recipe. The way that we're starting all of this in headless mode is important. As I mentioned in my previous video, when we run in headless mode, Goose cannot interact with us, so we have to be very clear about what it can and cannot do. We're starting out our recipe with some parameters that we're passing in, like the disk path to the recipe that the user submitted. The prompt will get us started here. You're a security expert with autonomy to scan and score a security risk level of a user-submitted Goose recipe. From here, we tell Goose to download anything the recipe is looking for, including external extensions, and to scan those recursively and to output a final score. For the sake of time, I'm going to speed up these video clips here, but we found that that prompt alone wasn't enough, because even simple recipes like greeting a user with a friendly hello message were being tagged as medium risk. While we certainly want to be careful, we don't want to be too aggressive here. So we had some back and forth with Goose, asking it to improve its process. And we ended by giving Goose a number of recipes ranging from simple greetings and low-risk instructions all the way through very dangerous and malicious instructions that could pack up sensitive files like SSH keys or API tokens and forward them to third-party servers. Let's go back and take a look at the rest of our recipe. So we tell Goose here that it can download whatever tools it needs to do its job and to do its own analysis of what it thinks is appropriate. We chose an LLM that is known to be good at cybersecurity knowledge, so Goose should be able to help score things appropriately. To take it one step further, we even gave Goose instructions about how to use a known open-source vulnerability database to scan any third-party libraries and packages. Down here at the end of the recipe, we give Goose instructions on a very strict format that it has to follow to give us its analysis so the GitHub action can correctly interpret the results. Through that back and forth with Goose, Goose actually wrote this recipe for itself, so it's full of detail about the kinds of things to consider, how to run things, and even provide a handful of other recipes for what to learn is safe or really bad. From there, it's scoring everything based on the criteria that it's determining as it goes, and outputs that as a recommendation and reasons for coming up with those scores. So there you have it, Goose running in headless mode to do security scans inside a Docker container, inside a GitHub action to improve our CI/CD pipeline. AI-powered tools are making things so much more efficient and give us a lot more flexibility in what we're doing. Give Goose a try in headless mode, and come join our Discord community and let us know what you're working on.